Welcome back, Math 30-2. Today we are going to look at using logarithms to solve exponential equations. So essentially what we're going to also look at is this rule here, how we have log BA, how that is actually equal to log A over log B. And I'm going to show you why that is here soon. So if I first look at this equation here, here's an example. I take a look at this. I have 4 to the power of x is equal to 7. Now that's confusing. I cannot change these into same base. If I can't change them to same base, I need to know this equation. What are we going to do? We are going to log it. So what is this in terms of logging? This is the same thing as log, or in base 4 to this is equal to 7. X. It's like that. So we're going to put that into our calculator now, and this is the same thing as log 7 over log 4 is equal to x. So I put that in my calculator, and I'm going to get some magical number. And my number is, right there, we see it, it is going to be 1.4. Okay? Well, there's another way of doing this as well. What if I just said, I know it has to be in terms of logs. So all I'm going to do is log both sides. So I'm going to get log 4 to the x is equal to log 7. Now we go by our rules from before. We know this x could go in front. So I'm going to get x log 4 is equal to log 7. Then x is equal to log 7 all out of log 4. And this is automatically in base 10, so we can punch into our calculator. And that's exactly what we have from here to here. So that shows you why this is equal to this. It's kind of a neat little proof there thing. So here's my next one. We want to do, so this is to 3 decimals. It's 1.404. 3 decimal places, sorry. Okay, so we did the exact value there first. Here's my exact value, then I did 3 decimal places. Let's try this next one. So first of all, what's the first thing we must do? We must isolate our exponent best we can. Because we're trying to solve for the exponent. So just like way back in grade 9 and grade 8, we isolate for the exponent best we can. So I'm going to get 8x, 8 to the power of x is equal to, I subtract 4 from both sides, 36. Now, how do I do this? Well, I'm going to log it. I could go 2 ways. I could go this way. I could say log 8, 36, x, and then switch that into log 36 over log 8, and put that in my calculator. Or I can log both sides quickly. So what am I going to get? Now I can bring this x down in front, so I get x. Now I divide both sides by log 8. So what do I end up getting? X is equal to log 36, the logarithm of 36, all over the logarithm of 8, and then base 10. So we're going to push that into my calculator here, my trusty calculator. I'm going to push in log 36, bracket, divided by logarithm of 8. And I get 1.72. 1.723. So I kind of showed you 2 completely different ways on how to solve those. Okay? Now we're getting into a nice little nifty word problem. Don't let the word problems confuse you. They are not that bad. It says, according to Statistics Canada, in the 21st century, Canada's population has been growing at an average annual rate of 1%. So it's 100% plus 1%. Okay? The exponential equation is, this is my initial population multiplied by 100 plus 1%. Can be used to determine the population P, where n is the number of years. So there's my equation. So I'm going to put that in. Okay, now it says, if the Canadian population at the beginning of 2001 was approximately 30 million, okay, so we're looking at 2001, It's 30 million, so that's my initial. It's 30 million. Okay? How many years will it take the Canadian population to reach 50 million? Well, I look at this, and what's the first thing I must do? First thing, isolate my exponent, right? Isolate for the variable n, the best we can. So I divide both sides by 30, and I'm going to get 5 over 3 is equal to 1.01 to the power of n. Now, I could spend forever guessing and checking on this. 1.01 to the power of what is equal to 5 over 3? I can't do that in my head very good, and I'll spend forever doing it. There's a faster way. This is why we need logs. We are going to log both sides. So it depends whichever way you want to do it. I could put in terms of logs. I'm going to do it both ways once again. So I could say log, and my base is 1.01. And then what are we having here? It's equal to 5 over 3. And we're trying to find out n. Okay? I could have gone that way. And then I use my log rules. I know this is log 5 over 3 over log 1.01. So I could have done that way. Or I could have logged both sides. And then I end up getting, I could put this n in front, and I end up getting the same thing. So I get n is equal to that as well. Okay? We could have done it both ways, logging both sides or that way. Now, here we go. Now let's try and figure out what this is. So, let's punch in our calculator, log 5 divided by 3. Put it in my brackets, make sure it's in brackets. Then we divide all of that by log 1.01. Put in my brackets. And what do I end up getting? 51.3 years. So, it'll take the Canadian population 50 million, assuming the same average annual growth rate, it will take 50 years. Oh, 52 years. Well, that was a bad one. 52 years. Because after 51 years, it's not quite there yet. It'll be at 52 years. It'll definitely be over 50 million, okay? Or we could put in fractions. So I say 52 years. All right, we round up for that one. Now, here we go. Consider the equation 4 to the power of x, okay? And now we're going to do this like we did before, is equal to 7. So we go into our y equals, and we put in 4 to the power of x, and we want that it's equal to 7. Well, my window, my x isn't going to be greater than 10, okay? My y isn't going to be greater than 2. Or sorry, my y isn't going to be greater than 10. My x, obviously, because 4 to the power of 2 is already 16, isn't going to be greater than probably 3. Well, it's definitely not greater than 2. And I'm going to count by 0.1. Instead of 3, I'm going to have 2. Okay? And I'll count by 0.2s. So I graph it. It's going to look like that. All right. And my other line's there. I'm going to calculate my intersect. So this way here is actually a lot longer because you have to think of your windows, and we get 1.403 or 1.404, which is the exact same thing as we got before. So we just graph it, and it looks kind of like this. And it intersects at 7 right there, and we find the intersect. Okay? Now we're going to look at different methods of solving. So if I'm saying this is equal to this, and it's logging both sides. So this is kind of what I was doing the first time, logging to bring down the exponents. So I was already showing you this, so to break it in, but we're going to try it again here. We want log 2 to the x is equal to log, I'm doing a first, 32. Okay, so it's kind of like what I was doing at the very beginning. I just broke it in for you. Now, what does this mean? We can bring down the x. X log 2 is equal to log 32, which is the same thing as, because we just divide both sides by log 2. That's essentially the same thing as what we did with the other one. Now, the reason why this one is nicer sometimes is because when we get to an equation like this, where I have 4 to the power of x is equal to 2 to the, 2 to the x plus 3, I have these exponents on both sides. That makes it a bit difficult. This one I could probably simplify. We could get them in the same base, and you could solve, but sometimes they can't really be together. If this was in base 3, because it's 4, it'd be hard to compress and combine together. It's like having 2 logs. So we're just going to log both sides here. Okay, now this means I could bring down my exponents. Yes! Okay, so, oops, missing my second part there. So it's x plus 3. Now this one here is kind of a messy way. So we have this, and now I have to multiply this. This log 2 is multiplied into both of these. We have to use our distributive law here. So I'm going to get x log 2 plus 3 log 2. We have to use the distributive law. This has to be multiplied into both. Very key. And then here we have x log 4. So now let's put all of our x's on one side and all of our non-x's on the other side. So that's going to be equal to, now, to solve this, we could do something neat. What is multiplied by both of these? X. So if it's multiplied by both of them, I could actually factor out an x. Let's factor out this x, and I'm going to get log 4 minus log 2. Oh, now, which is equal to 3 log 2. Now I look at this, what can I do? This is division. 4 divided by 2 is 2. Okay, now what do? I could divide both sides by log 2. Whoa, log 2 and log 2, don't they divide each other? Yeah. So then x is equal to 3. Look how neat that works. That was interesting. It may seem very complicated right now, but we're going to do a few more of them, and I'll help you tomorrow with some questions on that, and eventually you'll end up getting it, okay? Alright, so here, let's take a look at this next one. It says, so what of the solution? It wants you to put the solution in this form, okay? Can be written in this form. Okay, so evaluate. So we first got to put the solution somehow into that form. So how do they get that and then evaluate it? So let's take a look. First thing we must do, we're going to log both sides. Log for x plus 2 is equal to log 7 2x plus 5. Why do we need to log both sides here? Because I can't say 7 to the power of what is equal to this. It's too complicated. There's too many formulas there. So I'm just logging everything. Now, as soon as I do that, I know I could take my exponents down in front. This helps me get rid of exponents. How beautiful is that? So I get x plus 2, put it in brackets, is equal to, oops, that's supposed to have log 7. Now, this here, the log 4 is multiplied by everything there. So what must I do? That magical thing called the distributive law. So I'm going to get x log 4 plus 2 logarithm of 4 is equal to, now this log 7 is multiplied by both 2x and 5. So we multiply them in. All right, next part. Everything seems to be simplified. We have our x's. Now, let's try our best to isolate for x. There's no multiplication left, now we can isolate for x. Okay, so I'm going to put all my x's on, well, this side. So I'm going to end up getting x log 4 plus 2x log 7. Because I'm going to plus 2x log 7 to both sides. Okay? And then I'm going to subtract 2 log 4 from both sides. Okay? So we have this, and is equal to, well, this is gone now. This is there, and this is gone. We're left with 5 log 7, subtract 2 log 4. All right. Now, what can we do here? I look at this, both of these are being multiplied by x. If they're both being multiplied by x, that means I can factor out an x. So I'm going to factor out my x, and I'm going to get logarithm of 4 plus 2 log 7. And that's multiplied into both of these, right? All right. Next, what do? I just divide both sides by that. I divide both sides by log 4 to isolate for x. So I get x is equal to 5 log 7 minus 2 logarithm of 4 all over log 4 minus 2 log 7. Look at that. We have exactly what they have there. Almost done. Now it wants us to calculate this. So I'm going to move to calculate this way up over here. So the first thing I look at this is, I can't really divide these because there's numbers there. Doesn't work very well, does it? So I'm going to put this as, this is the same thing as 2 to the power of 4, or 4 to the power of 2. So we have log 7 to the 5 all over, because I moved that 5 on top, and I have that 4 there, and subtraction means we divide, all over 4 to the power of 2. Alright, now all of that is going to be over, well, log 4, this 2 must go to the 7, which is 49, so log 4 divided by 49. Because 7 to the power of 2 is 49. And then I'm going to punch this nasty thing into my calculator. Okay, let's see. Let's punch this in. Hopefully you can see that. So I'm going to go log 7 to the power of 5. Okay, divided by, oops, that's the wrong button. Divided by 4 squared is 16, bracket. And all that's divided by log 4 divided by 49. I end up getting negative 2.77. And that is how we solve this. This here would have taken you forever to guess and check. You would have been guessing forever. Here's the way of solving. Okay? All right. Last question before we go on to our assignment. This one here says, solve the following equation. And this is almost the exact same thing, except we're looking at natural logs. So here, what are we going to do? First, isolate for, it wants exact value, then 3 decimal places. First, isolate for my variable. Okay, so I get 7 x is equal to, I subtract 9 from both sides, I'm going to get 4. Oh, that's 3. Horrible math. Is equal to 3. Now I can log both sides, or, no I can't. This variable isn't done to itself, so now I divide both sides by 7. So I get e to the negative 2x is equal to 3 over 7. Now I'm going to use just our identity for this. So that's going to be log e, and then I'm going to have 3 over 7 is equal to 2x. Okay? That's what I'm going to say now. Is equal to negative 2x. All right? That there looks very confusing. But it is in absolute. So I'm going to divide everything by negative 1 over 2. So I'm going to get log e, oops, sorry. So I look at this, I'm going to get log e to the 3 over 7, and I have to divide both, or multiply both sides, or divide both sides by negative 2, so that's negative 1 over 2, or multiply by negative 1/2 is equal to x. Okay, so this is my exact form. Now to calculate it to 3 decimal places, I'm just going to go log, exact form, maybe we should switch the base. So this is the same as negative 1 over 2, and we have log 3 over 7 all over log e, okay, which is the natural log. So if I want to really do that, or this is the same thing as negative, this is the natural log, 1 over 2, natural log of 3 over 7, because it's in base e. So I'm just going to put that in. And times negative 0.5, and I end up getting 4.23. Okay? Oh, 4.236. That's actually supposed to be 4.24. Okay, so that's how I do that. Oh, 0.423. Oh, I'm reading everything off today. 0.424. Whoopsie. Okay? So that is how we do that. Or if you did it this way here, try that out, you'll get the exact same answer. Okay, if you plug that into your calculator. Well, good luck. I'll see you tomorrow as we work on these questions together. It is a bit of a tricky lesson, but I have confidence that we'll tackle this together tomorrow.